Quit. My last day at after last year's. Yeah, the weekend on that.
I wonder why I called out you.
Yeah.
You were his car.
It's like they call me and they're like, hey, on the shift you have to Saturday and Sunday, you'll need to reach out to us. And the shifts is still as you came in there. They would need to get those covered. Because I don't. This is for part time. So they're like, yeah, you don't. They're like, so you have Saturday and Sunday off, Thursday in store. And I was like, well, actually, I have class. So it's not going to be until 6:30. Yeah, I got well, this weekend.
That was the only class I had. That was part of the reason why I switched to computer science.
The questions are all.
Genetic assignments. Yeah, I'm just doing. Sounds like you need more.
Yeah, it's like,
Yeah, it might be more efficient. But confused. Yeah, you are supposed to include genetics in this assignment. Like how much work? Well, like how much?
Do you guys have any questions about the project? Good. Malcolm?
What's up?
Questions about the project?
Oh yeah, there's
Forgot. It was so important.
Well, it was only going to take me a couple seconds, but like the first question, it asks specifically about if Mount Everest is one of the tallest. Does that mean it's just in the knowledge base at all, or does it mean it's the tallest of all of them?
no, it means that's.
Because it is the tallest of all of them.
In the knowledge base.
In a knowledge base because I guess it's the wording, but the list is of the tallest mountains in the world. So
Okay.
it's just asking if it is one of the tallest, okay?
Thank you.
I could have answered that during the hopefully. Yeah.
I was just curious about the programming assignment too. If we worked in groups or in teams for that, only one of us has to submit, correct?
For the second project?
Yeah.
Yes. Yes.
Only one of us submits?
Only one submits. Make sure you put both names in the comment section.
Thank you.
Welcome back in person.
Made it. Almost the lunch.
If you have any other questions, you exchanged some text, but it's all good now.
No, I sent you all my questions.
Yeah, so the fold, right? You just sure you do. What did I say it was? It was
After 11B.
right to left post. No, I'm talking about the first question,
The,
the
yeah,
order
the
for
fold
fold
right
rights.
is right to left post order.
Post order, okay? Right, left, post order. It's completely. We never studied that order in CS2, right? Usually it's left, right, so it's like right, left, post order, okay? Do the fold right, or if you look at something like, let's say, 5. I think that's one that I didn't have any print out, right? So you
Yeah,
can.
fold left and fold right, we didn't have to do
You
it.
didn't have
It was
one,
just fold. I mean, you could have used fold left. Fold right, it would have been fine. If it
Let's
actually
say-
is addition, you could have used fold left or fold right, it would have been fine.
Yeah, so fold left and fold should be the same, right? But fold right is the one that I don't think I have a printout. Yeah.
Does it have to be post order?
It has to be post order, right? Let me think.
So it's left, right, group.
Yeah, because what you want to do, let me show you an example. Say 7 and 12. The order you do the computations should do 12, right? And then 7 minus 12 and minus that, right? If you're using, this is the operation, right? This can be anything. And then, so 7, this, right? And now we go this one and we do 1, right? And then 3, and then 5. Okay? So you do post order, so in right, left. So this one is evaluated before this one and then this. Now we're done with this right. We go to the other right. In this right here, there's no right, so nothing to do here. Left, and then visit the node. Now we're done with right and left, so we can visit this one.
That's if it's fold right, right?
Fold right. This is fold right. Right?
So I'm a little confused with the way that you wrote it on the board.
It should go to fold right of starting at 0, doing subtraction should go to 4.
Yes. So that's a different example, but if you use the 3-1 example, and you do a fold right subtracting, initializing with 0, you should get 4, right? If you want to use that to verify if you're doing it right.
Right now I have -4, so I still need to change it back.
Maybe, I don't know, maybe just the order.
Yeah.
Left to right, right to left.
Yeah. I think someone was trying to talk to.
Oh, I'm sorry. Yeah, go ahead. Alexander.
Yeah, so can you hear me?
Barely.
Oh, what do you mean by post order? So post order is when before you evaluate the node, you have to evaluate the children nodes, right? That's post order. Because you have pre-order. So pre-order, you evaluate the node, then you go down, right? In order, you evaluate left, you evaluate the node, and then you evaluate right. And then post order, usually you evaluate the left and right, and then the node. But this is post order right, left. So you evaluate right one first. Yeah, the leaf nodes first. But remember to do right and first and left second. Okay? Makes it look its left first. I think you're right. Let's use the example. So I'll get this right. set this right. So the tree one that you have is this one here, 2, right? And then 1, 7, and 3, 9, and 10, right? Okay, so so let's say let's assume that the operation is subtraction. Okay? And the initial value is 0. Okay? So you evaluate this node first, so you have to do 10 minus 0. Right? And now you're done with right, you're done with left, there's no left, so you can visit 9. So you're going to do 9 minus that one, right? Now you're done with right, you're going to do left. So 3 minus. You're done with right and left, you can evaluate this guy, right? Now we're done with this. This is right, you're going to do left. And now that you're done with everything, you can evaluate the node. So let's see if we get 4 here. So we got 10, 9 minus 10 minus 1. 3 minus 1 is 4. 7 minus 4 is 3. 1 minus 3 is minus 2, right? And 2 minus 2 is 4. That's how we got 4. Okay? Yes. Right? But the result would have been different if we would do left first and right second, right? Because you'll be evaluating, I guess, instead of 9 minus 10, you would do 3 minus 10 first. So it's important to do right first, then left. Okay? All right?
For average, do you want the float or can I have an int? Or when you're calculating the average?
Oh yeah. The list is of integers, right?
Yeah. Do you want the float like 8.666? Is that how you want it?
Let me see here because I did here, but just a second. Okay, so I'm suggesting you to use fold and size, right?
Yeah.
Fold because the tree is of integers. You're gonna do a summation, right? With fold, you're gonna get an integer number. When you use the tree size, you're also gonna get an integer number. So what you need to do is just convert size to double.
Yeah.
So you get the you said 1.6?
Yeah.
Yeah.
8.666.
Okay. Yeah, so just convert one of the values to double, so you get 8.66. Okay? Yeah.
So I implemented my fold using depth first, and I already submitted. Can I resubmit?
Oh, yeah.
Okay.
You can resubmit as many times as you want before the deadline.
Okay.
Not a problem. Cool. Any other questions, onliners? Yeah. I still have those food-related questions. Let's continue on that. I had 5 more because I can only do 5 at a time. There you go. So let's see. Really quick, so we can talk about this in prologue. Better do this beginning of the class so we're not too hungry. Can't read those symbols anymore. Okay, better look next time. Unify is because you have bread capitalized, it's a variable. How about this one? Ooh, croissant. Who likes croissant? My son puts butter on croissant. Do you put butter on croissant? That's insane, right? Do you put butter in your croissant?
Butter and jam.
Do you know how croissants are made?
I like butter on my butter. There's anything weird about
There
that.
you go. Because one time I follow a YouTube video to make homemade croissant. I was impressed. It's basically butter. And we were talking about fold, right? Croissant is all about folding. You do many foldings. It takes 2 days to do it. Yeah, I only did once. Too much work.
I've done puff pastry, which is like 1/1,000,000th the amount of folds as croissants.
More butter than croissant?
No, like 1/1,000,000th the amount. It's way less.
Less
But even
work,
that
okay.
is so much folding. It's fine.
So does not unify because you have 2 atoms. They are different.
We have 2 atoms. We have 2 atoms too.
You have 2 atoms too. There you go. Atom. They sound the same. I have so many words that, to me, because I'm not a native English speaker, they all sound the same. The other day, we were going to visit Golden High School for my son. He's going to be in high school next year, so he wanted to do the open house. And then as soon as we left the car, he saw one of his friends, and he said, "That's Carl, that's Carl." And he was running to talk to Carl, and Carl was coming with his mother. And I was like, "Don't call him Carl." I was thinking Carl the animal. But it was like a nickname or something. But it was like Carl, something slightly different. And I was like, later, and I said, "Why did you call your friend Carl?" He said, "What's wrong with that?" Then he explained. Then years and years, like, year and today, year, it sounds the same. It's all about the context, right? Whatever I say here, you guys understand based on the context. Maybe you don't. Just being nice. Okay, so you guys did really bad on this. It's not unified because, look, on the left side you have a complex term. On the right side you have a simple term, which is an atom. So it does not unify at all. Did you actually said that unifies because bread is considered food? Are you guys just making jokes? Is that it? Oh my gosh. I thought the quiz was easy. Come on, serious. Take the quiz serious. Are you guys texting each other and saying, let's ditch the quiz. Let's all do letter C. The most impossible. Because just having a hard time with the onliners today. Yeah. Okay, so unifies, and we have a variable bread, right? Is assigned the value food bread. Last one, how about this one? Ooh. You know what's happening is the mute button is layered on top of the symbol and is messing up with the symbol. So you have to move a little bit to your maybe left.
The nearest it's so many.
Or unmute yourself so I can read it really quick. Oh. Oh. Really, even with the unmute is not working. I don't know what's happening with clickers now. Okay, I can't speak up. All right. Okay, so this one unifies, and the variable bread unifies with bread value, right? Because we have the same name for the predicate, so that matches the number of parameters match. So the corresponding parameters should match, should unify, and that's it. All right. So let's talk about lists in Prolog. So lists in Prolog can be created by enclosing its elements in square. I think before we do lists, I think we have an activity. So let me just check that. Yeah, I think so. Yeah, this one is to review recursion. And the other one is based on lists. So let's do, before we do lists, I'll give you some time to work on activity training. The first question, you have a knowledge base that describes a maze. Think about points in a Cartesian plane, and you have the coordinates. So point 1 is connected to point 2. It's more like a graph, right? So those are the labels of the graph, the points. So I'm saying that 1 is connected to 2, 3 is to 4, and so on. And I want you to write a recursive predicate called path that tells you from which points in the maze you can get to each other points when chaining together connections. So you have to use recursion. For example, I know that I can go from 1 to 2, and that's it. But for example, the question is, can I go from 11 to 20, right? Well, 11 is directly connected to 15, 15 is connected to 16, right? So yeah, I can, there is a path from 11 to 20. So I want you to create a predicate called path that takes 2 parameters, the source and the destination, and returns true if there is a path, all right? So let's work on this activity. It's kind of a practice, a review for recursive predicates, and then we move to this.
Yeah, well, I already have some of the other ones done. Yeah.
Actually, the make string is one of the last ones.
Okay, yeah. No, that's gonna be a question.
What was that? No, yesterday. Yeah, yesterday
I
morning.
think it was 2.
Because you have your office hours on Monday, Wednesday, right?
So it probably was.
I think it was yesterday. Yesterday. But it does seem like. Was it Monday?
Yeah.
It might have been.
Doesn't we talk about?
I don't do it. I just don't know what I'm doing.
I don't want to have to do my stuff.
I don't know.
And then you're like, "Oh, I need to do that."
Always.
You guys are residential badass.
Yeah.
Yeah.
Just loose ends now.
Fix it, fix fold right.
Prologue.
I think we should fix all day. This would also- Yeah.
Turn on the TV.
For opening these, they're even worse now that you hit them again. Oh.
You're not tuition dollars.
Smell the mint to this.
All right. For mobile app development, like when this department should buy smartphones, should involve the
Really?
device.
That's.
Although everybody has
Yeah,
a smartphone nowadays, but yeah, it's good to have like a standard.
It's good to have one you don't break.
Yeah, you have, no, but if you break your paying.
What is the most basic, like, is there a path to A?
Yes or no?
Yeah, like how would you figure that out?
Are they connected?
Yeah.
So you just query if they're connected.
Yes, that's your base case, right?
Okay, so are we writing one query or?
It's the actions for the second query. It's just-
I think I would do that. So Fine. Yeah.
Trying to figure out like.
So I need X.
We need two arguments.
You know what you said? Yes. You didn't say anything. No,
So the first thing would be like x equals y. That's base case.
Well,
Well, it's connected, right?
base case.
So we just do connect.
So one point isn't connected to itself. I guess I was thinking there are two base cases. If I ask 0.5, 0.5,
Is
yes,
this
0.5 is
just the base
connected to
case?
0.5.
I think the question is a path, not
Yeah.
connected. So it should, yeah, have a path that has.
Zero edges, okay.
So that would be,
And algorithms too.
and then is it this?
Period.
Periods.
And we call it. Or I mean, we could do it in lots of dictionary. I think it's easier.
Yeah, definitely do it in one. You don't like doing it? Okay.
I was-
This one liner over here.
Okay. Now we need, so that's our base case.
Not a recursive case. No, they're the same.
Same.
Yeah.
So we just call it first again.
And it's silence, it's a different case.
So it's gonna be x one.
It's gonna be x, y from start. If.
No.
All, just go ahead.
You got.
Yeah.
Then say what connected,
So
x,
yeah,
x, z, and then, and so connected x,
Connected X and Z.
yeah, you need an intermediate,
I can hear you. Why?
and then, no period, we need to do an and, which is comma. Connected,
Connected Z, Y.
you download all that.
You guys done? Sort of. So not that.
Well, oh, you gotta do recursive.
Yeah, we don't have a recursive call right now.
You call recursive.
Yeah.
I can explore that. Oh, no, that's CY.
Yeah. If we found the activity suggestion path instead of recursive.
Oh, the spell. I'll make it up.
Don't forget the period towards the end there.
Yeah, I'm changing name.
So what did you say the school uses Prolog for?
Why is this it?
Didn't you say Prolog was used somewhere in the school?
So you just call
or
path
something? Like we have an application, we use Prolog. Something about Prolog.
There's no path.
Trying 13.
13 comment.
Hard to find. Should roll.
Real world applications are actually kind of what you had in the slide, right?
Yeah.
That didn't work, because 13 can go to 14, right?
Yeah, that's why X equals 14.
Starting at
There is a
13.
map.
Oh, there it is. Never mind.
There is a map.
Let me go through the. That makes it harder than I should.
No, you just download Spectacle and you use split
Once you
windows.
do-
Or I just do that.
That takes too much time.
It took me like 5 seconds.
Spectacle is just optioned and then
Spectacles.
it's just an extension that helps you with using the command option left and right. You can put your windows wherever you want.
Is that Windows specific?
Mac 6 to 18, it's free.
Can you name the
I think you can change the commands.
Can you read that?
I mean, make the
6 to 18?
desktops, because Mac basically renamed desktop.
I don't think so. You can't split windows.
Such a basic feature in So
So we're
with this
saying
one,
from
we can split in 1 and 2.
13.
Yeah, so like if you had these two windows, one was big, you can shift one left and one right, and then split, or top and bottom.
It's also got an
split,
HD.
or you can do full screen or.
And 13 can also go to. No. It goes to 10. That's great. Malcolm said he did it
I think
wrong.
we have it.
You got it?
I think so.
Off, bro. It's your fault. I didn't even take it out of the box, bro. It felt hard when I took it out because threw these on the ground. So
Try to see.
yeah, the one that fell out. No, I thought it'd be in one piece. I guess that's my bad. Yeah.
Space.
I like this example better than the frog in space.
No, they normally should.
Oh, the like with.
This makes more sense, yeah.
These ones. These ones.
Sorry, I only just know.
Got more there or what?
Use the map in the document.
Write a predicate twice.
Okay, easy, right?
Oh, which is.
It was one of the first one too because it landed on.
Okay, so basically you have to do path. So you start with the base case, right? Path x to y. There is a path if they are connected. This is the recursive one. Well, there is a path from x to y if x is connected to some z, right? And there is a path from z to y. Just by doing this recursion, you solve the problem. And here I'm showing that there is a path from 6 to 20. Look at the map. 6 going to 20, okay? So going all in this direction here. And starting at 13, you can reach all of these nodes here, right? So 14, 17, 18, 9, and 10. Those are the 14, 17, 18, 9, and 10. Okay?
I just sent them one.
And you can do the opposite, like which nodes can be used to reach, for example, node 10. Let's try that just for fun. So many nodes can be used to get to 10. That's kind of expected, right? 14, 9, all of these here, right? All of these in this path here, they can reach starting at this node. Actually, this one is also possible, 5, right? That's the biggest interaction here. And we have 5 here, so it seems correct. All right, so any questions about recursive predicates? It's very powerful. I mean, you can do a little bit more complex queries and rules, right? And make sure you start with the base case for optimization and then do the recursion second. Okay, let's talk about lists now. It's the next topic. We're almost done with the core of Prolog, so hopefully by next week we'll be able to finish this. So lists in Prolog can be created by enclosing its elements using square brackets, separated by commas. The pipe is a special built-in operator that can be used to decompose a list into its head and tail. That's the powerful operator that allows you to, because Prolog doesn't have explicit loops, right? So lists are important when you have a collection, and it enables you to iterate over those collections because you're able to process one element at a time using this pipe operator. This pipe operator will give you the head and the tail, and then you can use recursion to keep evaluating all of the elements. Most predicates that are based on lists, they are recursive, right? That's why we talk about recursion first. And usually the base case is the empty list, right? There's nothing else to process. That's the base case. That's kind of the template when you work with lists. Let's take a look at some example. If you have this unification, we're trying to use unification with lists, right? So everything you have to think about Prolog, you have to think in terms of true and false. So that's why in order to extract elements from a list, you have to do this sort of unification. So on the left side, this is a list based on variables. On the right side, you have the list with the elements enumerated, right? List of atom values, right? And we're trying to unify these two lists, right? Well, these two lists unify, and H, which is the variable that I'm using to represent the head atom, or the head element, is going to take the value A. And T, right? T is the tail, will take the list with all the elements but the head. Okay? So that's how you do the split. You take use a variable to take the head, and the remaining elements you use for the tail. The empty list, it's a special case. It doesn't have a head element. So if you try to do, for example, a list with only one element, the head will take that element, right? And the tail will be empty. If you try to do the same thing with an empty list, you get false, because this unification is not possible. There's no way there's no possibility of a unification that will make that true, right? Because there's no head element in the empty list. All right? Everything in Prolog is so logic, right? It's so logical. Of course, it's Prolog. So it's very flexible in the sense that you're not limited to take just one element at a time. If you want to take the head and the element that comes right after the head, you just use more variables, okay? So for example, if I want to take the first two elements, I can use X and Y. X is going to be assigned A, Y is going to be assigned B, and then Z is going to be whatever's left, okay? Sometimes you want to extract elements from the list, but you just don't care about them, okay? So if you don't want, you just want to get rid of the elements in this example here, I'm not interested in the first two elements. I want to get the third element in the remaining list, okay? So to do that, since I don't care about the first and the second element, I can use the anonymous variable. And we're seeing this in many, you're seeing using the underscore as anonymous variables in many languages this semester, right? We saw that examples in Haskell, right? We saw when you were talking about lambda functions. So it's very common to use underscore as this kind of wildcard. variable or anonymous variable. We saw that in Scala when we want to express a function, right? But we don't want to define a function, like when we do operations and we want to pass a function to fold or to do some mapping, right? We can use the wildcard to consume the elements from a collection. So here in Prolog, we also have that when we don't want to specifically name a variable. So let's now combine what we learned about recursive functions and lists and splitting lists in head and tails to define a predicate that will tell whether an element is a member of a list or not, right? Kind of like contains, right? You want to check if the list contains an element or if an element is a member of a list. So we start with the base case, right? Can you understand this base case? Its base case is not even using the empty list. Because the empty list is always going to be false anyway, right? Doesn't make sense to use empty list for member type of function. But what are we trying to do here? Trying to look at this pattern, right? X is the element, the atom, whatever, that we're trying to find in the list. The list is the second parameter, right? We're using variables here to express that if the element that we're trying to find is the head of the list, we found the element, right? So it's true, okay? But this is the base case. The generic case is when X is not the head. So we're using two different variables here to express that those values are different. We know that X is a variable, H is a different variable. So when that happens, it doesn't mean that we should assume false, right? We should still check if X is in the table. And that's what we're doing with this recursive definition here, right? So if X is not the head, we're gonna look at X in the table. Okay? Why don't you guys code that and check if that works? Really quick.
Well, right.
Yeah.
All right.
Oh, man, it's getting clear. This room is actually getting- Check the path, right? You look so tired. You look tired.
Okay, so we have it coded here. We can, for example, do member. Let's try, for example, number 4. It's obviously in this list here, right? So that's true. But that was the base case. Now let's see number 3, right? Now we have to use the indirection, right? And it's true, so it worked. It works with anything. Let's try 10. No, that's false. Okay. The list is empty. It should also be false. Let's try with the last element. Also works. Okay. Showing some examples. You can use variables. So when you use variables with member, it's the iteration. It's basically the loop, right? You do, for example, member X, and then you put the list. Say this one here. What is program trying to do? It's trying to assign values to X that will make that query true, right? Answer true. So for, it's one possibility. True, of course, right? But basically, we are iterating over the list. Okay, let's make the implementation, this implementation works, right? But do we need, for example, this table here can be anything, right? We're not even using it. So we can replace this with the wildcard. Another optimization, we are not using H here. We're using X and T. So we can also replace that with the wildcard. Okay? Still works. All right, so let's practice. Let you guys now work on exercise 2. Okay, so write a predicate called twice in out, so 2 parameters. Those parameters are both lists, right? So the second list consists of every element in the left list written twice. For example, on A4 Bogle X. Now, A4 Bogle, that's the list, right? And I want to ask, what's the second list? This is how the second list should look like. Every element should appear repeated. This other example, also 1 is going to appear repeated in the same order, okay? 2 repeated and 1 repeated, and this other one also repeated. Okay? So use your knowledge of lists and recursion, variables, the split, right? Splitting a list in 2 to figure out how to implement twice. Give you some time to work on the second exercise of activity 20. Same. Oh, you like that? No.
it's supposed to return. No. This. That makes sense. So our keys should be, the list is empty. Yeah, because it's empty, if it's empty, you just. That makes sense? Okay. Well, you can- use remake.
Passes, so this one just write this down. This is our query. You can say it's X in terms of that.
Yeah, it should return. Oh.
Yeah, I think so.
So we have to see, if, so. Since, so we're supposed to check,
Consecutive. Twice items.
so you check X,
Instead of
X,
recursing.
you check X.
So I guess,
What was the?
I guess this would be our base. Yeah, I don't even know. That way.
So we should be popping out every other item of the list. We should be popping out every other item of the list. Makes sense? So pop this,
Oh, you know what, you know what?
pop this, and then it should equal that.
Okay, so you know how we can do that? R, R, page change.
No, he showed us how to do this in those slides. He showed us the, like, where you focus on only the second one, right? Or the first one.
Right, but I'm saying we need to focus on those two.
No, you don't.
Like here in this,
You're checking that it's equal.
checking that, yeah. Whatever you do past it. Two curve, yeah, start doing, so like you need to check the first two result. Right?
See, this is why I'm confused. The query should be passing in A for row and X.
Ready? Did you figure it out?
Bring the whole squad.
Oh. Being weird.
There were nicer ways to do that. So it's not, it's not.
Big table.
Should be. I have twice right now. Not as far as it goes.
I guess you picked a good name this time.
So with the head tail thing, search, can we split into more than two pieces,
Yeah, you can put
Yeah,
like
so then
H
we can-
comma H.
yeah, so you do H and H2 or something like that and look at the first two, right?
The
Check
key
the
is if you
equality.
use the same name for the variable, Prolog understands that you're matching, right?
So
Okay.
this is even,
So even better.
it's
You don't
supposed to
have to do
return
an
a
equality
list,
check.
or it's supposed to return true or false.
So what if you do,
It returns true or false always, because that's the predicate.
Right.
That's how you work in
So-
Prolog. But what you do is you
Which
make
type
the
is it?
second list as your output. So you build, Prolog will build it to make it true. The predicate true, so it's like indirect.
Gotcha.
Yeah, you can't write like a predicate like Prolog that returns a list. No.
Right.
You make the second parameter or some parameter a list that you want to be the output.
Something like that,
yeah, yes.
but like, I'm not sure.
Well, I guess you can't necessarily, well, I guess.
The hint is, in this case, think about the empty list. Start with the empty list
Yeah.
as the base case, right? Because your goal is to reduce the list until you reach the empty list, right?
Yeah.
But the base case would be,
So,
Does that start with the empty list?
show them what you did. That's what you can start with.
I'll just write it, yeah, if that's accurate. Like, that was my. Check the box, I think it's doubled.
Just go with more brains.
So, yeah. That makes the first one. I think,
I can copy and paste, guys.
shouldn't we do, shouldn't we check
Well,
if there are
but
two
then it's
X's at the
gonna-
beginning as well? Or is that not?
2 X's at the beginning of one.
Like X comma X pipe X.
Aren't we already
Well,
checking?
we're
if
checking
there's
the two.
X's?
Yeah, there's really two X's. at the
Yeah,
beginning,
the
arbitrary.
wild card is where I.
Oh, well,
Yeah,
you have
that's
an
where
X
I'm not
comma
sure about
X.
as well. That was like,
The wild, because that would skip the next one.
but I think what I was worried about was if it was just TP, that it would then be wanting it to be like, say you entered 1, 2, 3, then it would want it to be 1, 1, 2, 3, 2, 3.
What if it's just that? Because then it
But then we're
checks.
not checking if the tail is duplicated, we're only checking if the first thing is duplicated.
Right, but we're gonna make a recursive call.
Yeah, but this is supposed to
This
be
is-
base case. I don't know.
Well, I think your base case is, you're talking empty list or whatever, right? Like, if you get an empty case, then that's your base case, that's just false.
I don't think this base case would return false, this base case would return true as long as the first number was duplicated.
Yeah.
They wouldn't care anything about the rest of it.
Why is it X comma X and then pipe T? Why is it comma?
Because it's making it
Yeah, you
a
need-
second list, that's T.
it's saying we need this X and.
Yeah, you're saying like-
Like-
Look at the first two elements.
Like, look at this example on the slides.
Because we're checking if you're duplicating and then
Okay.
recursive call.
Close.
That's
Next on that.
my thought process.
Yeah.
Because if we're always gonna check that it's a do. But then tail down, or we should end once it's empty.
I think.
Right?
Now you
Does
just
that make
need to
sense?
do if and only if.
Yeah, so it's,
Yeah. Now you just do if and only if twice.
Oh.
T and.
I guess that could be interpreted as like G that's left over is.
Yeah, that's my thought, 'cause especially if you're gonna be popping off every time, like if we have something that's just one, and it's not empty, and it's not duplicated, it'll return false. If we have something that's, yeah. I don't know, I'm tired. I also don't know how to check the emptiness, so we'll go type measure.
That just work. Get rid of, this.
And then X. It's not reversed.
Bro,
So you guys are 1720. Wow.
look at Smarty Pants here. I think.
I just figured you had to change this.
Hold on, we're taking this. Is that okay?
No, don't give it to me. No, don't give it
You
to me.
gotta show.
Here, show it to me, I'll type it
No,
out.
it was just, I just started with the base case of top, so twice with 2 empty lists,
Yeah,
and then
wait, so you did it twice with 2 empty, comma empty,
yeah,
and then what?
and then change this to T and then that one to Y.
Change what?
This one to Y, sorry.
This one to one? Okay,
No, the last one.
oh, this one.
Yep. 2 X's. And then if and only if, and then you call twice again. And then with T and Y. Colons. Just
T and one.
yeah, with the
T pipeline?
or common ones.
You got an error on 27.
That's because it's a period.
That's right, huh?
Yeah.
Yeah, this guy.
Is it working? Good done?
Good for you tomorrow.
Good done too.
Yes.
Like I literally only had it not for
Yeah,
And like,
I was right about the base case,
Yeah,
so
well,
that's the only thing that
what makes it
matters to me,
recursive.
okay?
That's because that's what's gonna make it.
I don't know, I feel like the person who like decisively acts always wins over the person who like, we can be as right as we want, but it's good, we don't actually do it.
I'm just proud of myself for knowing something. Yeah, cool.
Look at that.
Yeah, makes sense.
Oh, that's good. Yeah, don't touch it.
Did you flip X? Put X, see if it, X has the first parameter. Did you do?
X is the first parameter?
You flip, just to,
Oh.
So like,
yeah, put X as the first parameter,
And then the second one.
and the
has a
second one as the duplicate, see if it reduces.
that's the dupe and redupe.
We'll make a palindrome out of this.
Yeah. Look at that prologue, come on.
Awesome job, Al.
It's not bad.
Line it down so much, okay, just put the base case.
Dude, I literally that's all I did.
We solved it.
Dude, but you also changed, right?
Did you try?
This was Y, right?
Yeah, so we
This.
had them the same, yeah.
You
Step
should
up and give you
exhibits,
one
right?
more.
Oh,
Oh,
So create a predicate, so the first parameter is the empty.
This, I changed it.
What's the second
I
parameter?
was,
It should look like empty, right? There's
I had another rule in there in the middle.
I'll try to do the return using
That
patterns.
makes sense.
Just reading.
Now the other one, you should choose.
I don't like it. I like it. This is.
It's really straightforward.
I also,
No, it's straightforward.
I'm also gonna be honest.
Figure out
Has a
how
lot
to
to
do
do
it.
with it.
I'm gonna stay home.
So, if you guys,
Yo.
the idea
Suddenly feeling really itchy.
is if you look at,
Me too.
That's kind of bad.
you start with the basic case, like if the first list is empty, the second one has to be empty. If the first one has just one value, let's say A, the second one needs to have two A's. If the first one has A and B, well, how can we go from here to here? Well, we can see that we look at the head, right? And the other list is just B, the tail. The other one, this head should appear twice, and the tail, right, also should appear twice, right? But we can't check the tail because the tail is a list, right? We use the recursion to check for the tail. Name this tail, some T1, whatever. This other tail, we don't know what it is. Let's name T2. But at this point, focus on checking if this matches 2 for the head. And then you recursively checks twice, right, for T1 and T2. Eventually, since you're always taking one element, you're going to hit the base case. If there is one extra element, like let's say C here, that is not duplicated, or I mean C here, right? This B will duplicate, right? And when you go from here to here, you're gonna see the list. You're gonna see the C, but you're not gonna see. You're gonna see the empty list on the other side, on the second parameter. And you can't move forward, right? In order to move forward, you have to always check the heads and the tails. Eventually, they need to be empty, right? Because you're always going to check. You take one and you take twice from the second list, and those values need to match. Okay, so the base case, empty list is the first parameter. The second parameter has to be an empty list. The generic case, you have H as a head. On the output list, on the second list, you should be able to see the head twice, right? Duplicate. We still need to check T1, which is the tail for the first list, and T2, but what you're going to do is saying that this is true, right? This is true. If I see H duplicated, it's true only if it holds true for the tails, right? So you pass the check using for the tails using the rule, using an implication, right? This is only going to be true, right, if twice applied to the tails is also true. Because we're always taking one element from the first list and two elements from the second list, eventually we're going to hit the base case, and that's how Prolog will figure out, oh, that's the base case, it's true, so everything previous to that is also true. Okay, so it works Doesn't matter if you use the variable on the right, on the second parameter, or on the left, the first parameter. So here it duplicates. See here it's duplicated, and here it reduces or eliminates the duplications. Okay?
Something like that.
All right. So let's move forward. Can you guys work on the third one?
I can type it up there.
This gangster.
I'm not sure.
Yeah, I know.
It's basically exactly the same thing.
So you have the knowledge base that translates.
Good.
Translates from Portuguese to English, the first 10 numbers. And what you need to do now is create the list PN, Portuguese, English, that will be able to translate. And again, you have to think that, understand that Prolog is based on predicates. So you have to write a true-false function, like, right? Always true-false. So in order to create a function that translates a list in Portuguese to a list in English, for example, you can't make this function return something. What you need to do is make the second list as your output list. Okay? So how would you do that? Very similar to, it's actually easier than the twice. Also, you try to use the base case using the empty list. There's nothing to translate. The output should also be empty.
Is it UM or U?
UM.
I know.
That doesn't work.
It's the glare. Progress. I'm just getting older. You'll admit it.
Yeah.
Cool, so that.
Pretty simple words. Yeah, it's just you start playing with your second objects more than you start the first. That's great. It's gonna bring it wrong page to I saw it. $600. I got sick of coming over here. Yeah.
I would have to change that. Then I have to.
This is gonna outlast me.
You always saw someone with school education. I can file my membership. Let's do this. Get some Kindles for school. Oh, I guess let's get off.
Oh.
There we go.
I see.
See the confusion.
Who is that?
Oh, that's right. There we go.
Oh. Jeez.
Basically just going off of.
Does it work the other way though?
Sure it does.
Like X and then one. It do.
Something almost like.
12. It just says false.
Yeah, sure, just. Can I do like check? Check it out, possibly. Type. This can literally translate any word. It is a full, we have everything.
No, what I'm saying, like, if you put in one list, like, if you had some English and some,
Look at the way the words are set up. Is that extension?
Well, it'd have to be Portuguese, English.
are you sure?
Yeah.
It'd have
I
to be
think it
Portuguese,
should be
English.
able to do it, right?
It should have
Oh,
something.
we might be able to do.
I don't know what you're asking.
Well, I should understand and not say false, it should say false.
Code that in.
Wait, I'm.
Like, if you type in like 1, 2, trace, will it give you back?
I think you'd have to try to write another.
Yeah, you have to write it.
Or have more,
Is that?
You have to do what the Harrison's doing right now.
yes.
Yeah, that would.
It's probably correct. We're going pretty hard on prologue last
Wait, why do you have to, why do you need that second?
Because you do.
to go the other way.
PPL.
Why does it?
Harrison, can you comment on that? Show out why you need the rule?
Because otherwise,
It's
with
only
the
going
first
one
rule,
way.
it is only looking to select.
It's looking one way.
Yeah, it's only looking for, is the first word, is the head of the first list Portuguese, is the head of the second list English.
Oh, okay.
So you need to switch it around the same. First list is English. The second list is Portuguese.
That's kind of what you look at first. Actually, it's just.
You have a word that's the same. Let's see.
Oh, yeah, you're right.
What if you, what if you just the reverse?
I get what you're saying, yeah, if I want there already, oh, yeah, then it's an order.
Good point. Well played. Didn't think of it that way. No need to rude. What? This? Yeah.
Say that.
had it for me, but that's the top.
Okay, I don't know what I'm doing, guys. X code?
Yeah, that's why you need this. So this needs to be true.
Yeah.
Finding the values.
Or like,
The thing that made me want to die was the capitalize the first letter. Me and Adam had the thing in a different spot for about 8 hours of us just sitting there.
We just had a brain fart. I think we were just like, how is this happening? Came to realize.
two capitals.
Oh, no, it wasn't even that. It was our make string.
We kept buffering
Yeah.
And we were like,
we were buffering an extra space. We didn't know where it was coming from, so I was throwing it to
There's definitely a bunch of things where like, if you keep trying to correct one thing and it's like, no, it's actually, it's entirely different thing, it's not this issue.
Which T2 for this?
All right.
Is it a this?
I need to edit my full right, I just wants me to do that.
How about this? Start with the base case. The two lists are empty. That should be true. And generic case, you have a list that you're able to have. This list has at least one element, calling it P. The other list, which translates, I'm going to call it E. And this is all only going to be true if P10 holds for E. So E translates P, right? And when we apply recursively, P10 has to be true for the case. Okay? Here are some examples I'm testing using variable as the second, so I get the list in English. Using the variable as the first one, I get the list in Portuguese. Okay? You guys feeling a little bit more comfortable with lists and recursion in Prolog? It's pretty neat, right? It's interesting the way that was implemented.
each time you just call it.
Okay. I have another unification with food-related unification. Let's do it. That should finish that sequence of
Yeah, that's why.
food-like quiz. The sequence of quizzes were like torture.
What class have you taken?
All the.
Oh.
Intro to text writing. That's
But
it.
those aren't prereqs to it.
They are,
Yeah, they are.
yeah.
We're doing
But I only.
But I only just decided that I want to be a sketch major and be doing all those next fall. That was literally not enough to take it, I have to do the other one.
Because I have a.
Not this yet. Well, I'm already like not major, so.
That doesn't sound fun.
86%.
I guess.
Okay. Of course, we have bread, we have croissant, we need coffee.
No, yeah.
Look at each other's eyes here.
Sorry.
That's why I barely got
Okay.
That's why I barely got my math minor. Oh, yeah.
You know those things with like poses? You have something like that for this should be.
I've been turned off.
Good luck spinning that up.
I'm sure you did. You hit the X. You have to go up.
I think it's two.
I'll be here anyway.
Unification is not possible because for the first
Like, never mind.
x, you're going to unify with red, but then you can't. Oh, it's even worse. The number of parameters is different.
There's also no Y in it.
Yeah. The question is actually a vision test. Can you read it?
Dude, I need new glasses, okay?
Is it better?
Right.
Good. You figure out what y is? You still want to see the expression, the code? Five more seconds. Got it?
It's like gambling.
I scanned you, Malcolm, and you didn't even notice it. What? I scanned you and you weren't, and you didn't notice.
Oh, no, so it's wrong now.
Yeah. You left your blinker.
I have to close it out after I'm done.
Well, you gotta fix it first, though. That's what I did.
That was mean, huh?
That was.
Okay. All right, guys. 36%. X times Z. Correct? Why is that? So basically, we're checking X is greater than 0. X1 is basically to make it the recursive predicate call. This Z here will be using this formula here because Y, which is the answer, has to be X times Z, right? Because Z is the factorial of X minus 1. And we still need to multiply Z by X. How? Remember that? Maybe you want me to refer back to the previous one? Do you remember the order of the parameters? How would you do the factorial of 5 using Prolog, using previous function, which was this one here? Another look. Just figure out who's the input parameter, who's the output parameter, to answer the next question.
Yeah, you're right. It's-
I'm gonna scream. Yeah, I don't think we're in the same boat as we have 5 rules.
Good. Or 5x. All right.
That's right. You're right.
Paying attention.
Okay, so this will be the last lesson on last set of slides on Prolog. Not yet. Yeah, this was actually, still have some minutes, so let's at least talk about the first 2 topics. I'll share the slides later. So one of the type of software that Prolog is really good at, or it's a good fit to use Prolog, is to develop what we call expert systems. So what are expert systems? So it's a software that basically uses a knowledge base to assist in decision-making process. For example, you need to select one of several hypotheses or make a solution that meets requirements. So if you so problems that have lots of constraints, you can specify those constraints using logic, right? And then you want to find the solutions that satisfy those constraints. Prolog is really good for those type of problems. The type of expert system that we're going to talk about is going to be based on user interaction. And you're going to use that for your next project. This project is usually fun to do. Students tend to like this project because it's an open project. You can create your expert system using anything you like, right? So you just need to fill some requirements, but because the system will use will ask questions, we need to understand how you do user interaction with Prolog IO. So first, how do you print something? So you use a predicate called format that takes two parameters. The first parameter is the format as a string. The second parameter is a list of things that you want to print out. So let's see if this link still works. Yeah, it still works. Okay. So you guys remember the to remember here, I think the tilde is like /n, so it's an enter. There are some formats that you can use to do the replacements. Okay, so special sequences starts with the tilde followed by an optional numeric argument. You see the F here, F means float. And the letter you're going to use, yeah, F is for floating point. D is for decimal numbers, like decimal is an integer. It's very similar to the string format in printf in C, if you guys are C++. Use the same letters to represent, for example, F for floating points, D for integers. I'm trying to remember the exact, see if the slides clarifies that. Okay, so the slide has a little bit more information on this here. So format parameter is a string, so you have placeholders. A typical placeholder starts with the tilde. You use W for strings, D integers, F floats, and for new line, as I said. Format internally calls write. So just remember that the arguments should match the placeholders. So if you have, like this example here, you have one W, right? So W, remember W is for strings. So this should match this string here, okay? And T, I believe it's for tabs, right? Let's see. Yeah. So T is used for tabs. So basically, I want to show 46. Doesn't make sense. 46 tabs. And then, yeah, maybe the title it wants to be split by 46. And then you have this other W, which matches this guy here, right? And then you have a pipe, and it's trying to create like a table-like format. We probably will, you guys will not use format, but let's move on. Format internally calls write one. If you just need to display a simple string, you can just use write or write ln. So let's try that. For example, write ln, then you pass a string. So, and that's evaluated to true, but you get the output, right? Let's try a format. So let's say I wanna see what that number will do for a W like this. I guess I'm gonna put a exclamation here. I didn't do much
Is that limiting the amount of characters?
of this one here, right?
Yeah.
You might be right.
Two, if you.
Yeah, let's put 2. 2W. Yeah.
What is the explanation right there? What's the explanation of the-
So I know where it ends. But actually, we had the tilde and a number, right? So let's see what that has to do with. Let's say done. Okay. Let me check the documentation. It's been, of course, after one semester, I tend to forget these things if I don't use, and I don't use Prolog very often. So I'll review this formatting. It's not going to be very important for your project. We're definitely going to look at the input, how you read information. Basically, we're interested in reading yes or no, because your expert system will basically if you just use the standard implementation that I'm going to suggest, you're just going to ask the user yes or no questions. And based on that, you're going to build a dynamic knowledge base. So that I want your expert system to be smart enough to learn from the user's answers. So we're going to talk about going to discuss a framework for this expert system that you can adapt and use for your project. Okay. All right. I'm done for the day. Have a great weekend. See you guys next week.
Yeah.
Pretty good.
I needed my mom.